25. 25 is set up in such a way that it has you being asked to plug in what value times x is added to 1 to create the scenario they gave you. They gave you the domain of 1, 2, 3, and 4 with a range of 3, 5, 7, and 9. What did they multiply by x and then add to 1 in order to get this output? Okay? Now the easiest way to do that, if I want you to look at it this way too, y equals mx plus b. Right now we're missing m, right? M is the piece that's missing. Do I have x values that I can use? Yeah. Do I have y values that I can use? Yep. And there's a b value. So I can kind of rewrite this using any pair, and I'm going to pick the easiest pair, to try and solve for x. I'm sorry, to try and solve for the missing, and I'm going to call it the m value because that's what I'm missing. So I'm going to use y is equal to m times 1, otherwise known as 1m, 1 times m, 1 times m, plus 1. So that means, looks like m is equal to 2. That's my guess anyway. I would do just one more to be sure. I already know that is the answer, but I'm going to do just one more to be sure. I'll do this one. 5 is equal to, the x value is 2m plus 1. 2m is 4. Looks like m is still 2, isn't it? Therefore, the missing piece for that equation, for that function, is 2. That one's easy. Going to do number 27. That one's a little trickier. 27 is this function is, nope, it's an h function, Mrs. Myers. H of x is something to the x power. Something to the x power. Can I figure that out? I probably can. Using what they've given me 1, 2, 3, 4 again, and they've given me 2, 4, 8, and 16. So the x values and the y values, and we can solve from there. Let's try it. 2 is equal to what number to the first power? Anybody know? Yeah. N has to be 2. All right, let's do one more just to make sure. I did this one. Do this one. 4 is equal to what number to the second power? Is it still 2? Yeah. Once you have solved 2 of these, you can be pretty sure that you're right as long as you came up with the same number both times. Because x value is what?
Oh, yeah.
So I'm plugging in the x value as the exponent and the y value as the h of x. Okay? Everybody okay? If I were to test a third time, it would be 8 is equal to what number cubed using these. In any case, I would still have come up with 2. So that's 26 and 28 for you in a nutshell using these examples. I'm going to do 29, 30, and 31 next, and we'll practice one in the next section too. All right, so 29, give the domain. So this section says, give the domain. And what that means is what numbers can be x in these functions. You might be saying to yourself, well, there's a majillion and one different numbers that can be in most functions, right? Take, for example, number 29. F of x is equivalent to x cubed minus 2. This isn't designed to be a trick question. What I want to know is what numbers could be x. Well, Mrs. Myers, they didn't give me a y value. They didn't give me an output. That's true. But let me ask it a different way. Is there anything that could not be used in the land of real numbers? Like produce some unknown, imaginary, weird number. In other words, all real numbers can be used and create real, workable solutions. Take for example, 0. If I put in a 0 and I cube it, subtract 2, I get a negative 2. Is that okay? Can I do that? Sure. If I take a negative 1 and I cube it, negative 1 times negative 1 is positive 1 times negative 1, negative 1, negative 2, so negative 3. Is this okay? Absolutely. In other words, all real numbers can be used for this scenario. (31) asks for this function, what could be chosen for the domain, x squared added to 3. And I say to you, what can't be used. Don't try and ask yourself what can be. Think what can't be. 0? Good guess. But if I square 0, what do I get? And that's a great way to start the thinking process. What Dylan was doing was looking for how this becomes a 0. In other words, if the denominator becomes a 0, then you have an undefined magic trick, and it doesn't work. Are there any ways to make this equal 0? Nope, there's nothing I can square. Is there anything? There's nothing I can square and then add 3 to create a 0. In other words, all real numbers can again be used. Where it starts to get a little bit tricky is in number 33. In number 33, we have f of x is equal to 1 divided by this trinomial. And using the same question that we asked before, is there a way to make this a 0? And the easiest way to discover that is to first factor it. And this one is x plus 3, x plus 2. I know that because I already factored it. Okay, I know we haven't done that again yet this year. But in factored form, this trinomial looks like this. You guys with me? That being said, what numbers for x can create a 0? Well, if one of these two factors is a 0, then the product would be a 0, right? What would cause this factor to be a 0? -3 would create a 0 here, and then 0 times -1 is 0. How about over here? What would create a 0? So the answer to this is all but not the things that would cause this to 0 out. 0 times 6 is? You're talking here, this is this is factored into that. X squared plus 5x plus 6 is x plus 3 times x plus 2.
So if 0 works for the equation, then all numbers.
Wait, ask your question again.
If 0 works for these equations, then it's all numbers.
Not necessarily. Because 0 works here, 0 plus 3, 0 plus 2.
No, I'm turning it like.
Yes, it's a denominator situation. If you, it's none.
Okay.
Yeah, none or whatever causes the 0 in the first place. So generally speaking, you're going to find that there are things you'll exclude, and then other numbers would be fine. So in this case, the entire universe is perfectly acceptable in this function except for these two numbers. Everything else would work just fine. Take a look at number 34 real quick. It's already factored. So what numbers would cause that denominator to become a 0? 1 and -2. In other words, you can use anything in the universe except those numbers, because those numbers will 0 out the denominator, and you can't do that. Number 32?
Would it be not positive or not?
Yes. Anything greater than a half will work. So I'm going to show you really quick. Square roots are positive numbers, right? Positive numbers. Numbers greater than 0, positive. And they don't have to be perfect either. They can be like goofy. If I said the square root of 3, you would go 1 point la 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 la. Even though it's a goofy number, it does exist in the land of real numbers. But if somehow I made this a negative by, let's just say, okay, how about x is 0? Let's test 0. Then what I have is the square root of -1, which you're going to learn about later this year. But in any case, is that a real number, and a workable number? No, there is nothing that you can tell me that is the square root of -1. So the only way you could come up with a normal real-world solution is to find a way to ensure that whatever is under the square root symbol, under the radical, is a positive number only. Not even positive, above 0. Okay? And the only way you can do that is if you select numbers that are greater than or equal to 1/2 for your domain. Every other thing in the universe that is below that will not work. Anything lower than 1/2 will not work. Because you cannot have anything below 0. 0 has a square root. 0. Okay? Anything that causes this to go below 0, I think I said above 0 before, but anything that causes it to go below 0 will create an impossible situation. So you must have numbers above 0. And that's what this whole exercise is about, challenging you to think about when numbers would work. We're going to do one more We're gonna do number 39, which gives us two functions. It gives us the f function, which is x squared minus 1, and it gives us a g, which is 1 minus 2x. That's what's being used for this entire thing. And number 39 wants you to find the f value of f at 2, and it wants you to find the f value of 2f at 1. Start at the inside first. It's funny, neither of those are using the g. That's fine. Start at the inside first. And both of these appears to be using this scenario here. Let's do the f value at 2. Plug in 2 here. What do I get? 2 squared, which is 4, minus 1, which gives me 3, right? That means the innermost function has been solved. Now I have to find the f value at 3. What do you get, 8? Next one. Double the value of f at 1. Double the value of f at 1. So f at 1, 2 times 1 is negative 2. 1 minus 2 is that negative 1? What's 2 times negative 1? Negative 2? Say again? So f value at negative 1, at positive 1, 2 times 1 is negative 2, it's a negative 1, double negative 1, and you get a negative 2. Oh shoot, I'm doing the g. Yes, dagnabbit. Ugh. I told myself, don't do that. 2f at 1. Thank you. F at 1. 1 squared minus 1 is 0. Double it. 0. F of 0 is going to be negative 1. Okay? So whenever they put a coefficient in front of that value, you're just doubling whatever the f at 1 is. In this case, it didn't matter, it was 0, but you're just doubling it. So I wanted you to see that in case you do see it later in your future. You'll see that in number 40. And be on the lookout for this dumb mistake, accidentally